Hi everyone, I'm Kyle, and today we're going to be looking at one of the underlying laws of our universe that everyone already knows but seems to forget. It's called the Law of Conservation of Matter, also known as the Law of Conservation of Mass. They're the same thing, and they basically say that matter, or mass, cannot be created or destroyed. Now, this is one of the coolest things about our universe, and we're going to come back to why that's the case later, but right now let's take a few minutes to develop a model to make sure we're all on the same mental page. Now, in physical science, just like other sciences, we use models to help us take something that's really big and put it into small chunks which are easy for us to think about. Now, models don't always work 100%. It doesn't mean we can't use the models. It just means that you have to know where the limitations of the models are so you don't use them in the wrong way. To help us model this law, we're going to be using these lovely building bricks. Okay, we're going to start with a red brick and a blue brick. We're going to put them together, and we have a blue brick and a red brick that were separate by themselves, and now we have them put together into something that is new, yet is very clearly made up of the things that we started with. Now, we need to think of a way that we can show what we just did on a piece of paper so we can send it to our friend in another room, and they know what happened without actually seeing what we did. Now, think about that while we go on to something else. We're going to throw in our yellow brick now. Okay, so we are going to take our blue brick, we're going to put our yellow brick on top of it, and then we're going to put our red brick on top of that. Okay, so we started with 3 distinct bricks, and now we have a stack, which is 1 unit, and yet clearly made of all 3 starting materials. Okay, so we are going to try to figure out a model that we can make that shows what we just did in a way that's easy to comprehend. And here we go. We started with a blue brick, a yellow brick, and a red brick. We put them together and ended with one tower of bricks made from the 3 individuals we started with. So we had blue plus yellow plus red gives us the final stack. This is what in chemistry is called an equation, and is the model that scientists use to show the combining of different starting materials, or to give them the fancy proper name, the reactants, into their final combinations, or the products. Now we have 3 of these blocks, so let's make some more real fast. That's better. So here it looks like we have 1, 2, 3 red bricks, 1, 2, 3, 4 blue bricks, and 1 yellow brick, for a total of 8 bricks. Now, I've never been very good at coming up with designs to make these, so let's just connect them all into a wall. Hey, don't make fun of the fact that it's a wall, I'm doing the best I can here. So here's my wall. Looking at the wall, we can count the bricks by color and see that we have 3 red bricks, 4 blue bricks, and 1 yellow brick for a total of 8 bricks. Now I know you're rolling your eyes saying, of course it's the same, that's what we built the wall with, and I want to say, great, that's exactly what you should be doing. It turns out that every chemical reaction takes the starting bricks and rearranges them into something that's completely new and yet still made of the same things. I know you love math, so we're going to add some numbers here and look at a little bit of the math that goes behind this. Go back to our previous 3 bricks that became a stack. Here we have the equation we made that is used to model the combination of the bricks. Turns out we can kind of treat it just like an addition problem when it comes to how much mass each of the reactants has and how much mass the product will have. If the blue brick has a mass of 2 grams, the yellow brick a mass of 1 gram, and the red brick a mass of 4 grams, then how much mass does the final stack have? If you said 7 grams, then bravo! Since the product has 1 of every brick, we can see that the masses added together will give us the mass of the final stack. Let's try the same thing with my beautiful wall. Hey, I said don't laugh at it! Alright, so let's count up our number of each colored brick. We have 4 blue bricks, and we said each blue brick has a mass of 2 grams, so that's 8 grams of blue bricks. We have 3 red bricks, and each one has a mass of 4 grams, so that's 12 grams of red bricks, and the single yellow brick has a mass of 1 gram. We take the mass of the blue bricks, plus the mass of the red bricks, plus the mass of the yellow brick, and we find that the wall has a mass of 21 grams. We can apply the same idea to an actual chemical reaction, so instead of the equation looking like this with our bricks, let's make it look like this with some atoms of hydrogen and oxygen as they react to produce water. So on the left side of this equation, we have our reactants, or what we start with. We have 4 total atoms of hydrogen, and you can see that they're good buddies and bonded together in pairs. With the oxygen atoms, we can see that they are also bonded together, giving us a total of 2 oxygen atoms. Now, they undergo reaction, split apart, recombine, form H2O or water, and we have 2 molecules of that. So our products are the 2 molecules of water. Now think about it. Water has completely different properties and behaviors than either hydrogen or oxygen, but it's still made up of the same atoms. Look at this the same way you did the bricks, and we can see that we started with 4 atoms of hydrogen and 2 atoms of oxygen. On the products, even though they are arranged completely in a new way, we still have a total of 4 hydrogens and 2 oxygens. Whatever you start with, you have to end with. They can be rearranged and combined in different ways, but we cannot magically create another atom or get rid of one. The same thing goes for the masses of the reactants in the products. If the 4 total hydrogen atoms have a mass of 4, and the 2 oxygen atoms have a total mass of 32, then we know that the product, or the waters, have to have a mass of 32 plus 4, or 36. This comes back to the law of conservation of matter and mass. You cannot create matter by making a new atom, nor can you destroy one of those atoms. The atoms you start with have to be in the final product. The mass is the same way. The total mass of the reactants has to equal the total mass of the products. Now I said we'd get back to why this is one of the coolest laws, and it comes down to this. The matter and mass in the universe right this instant is the same as the matter and mass that was at the very beginning of the universe. It's the ultimate recycling program. Everything is reused and remade into new compounds, new molecules, and new things. Okay? That means, if you think about it, the air you're breathing right now consists of oxygen, carbon, nitrogen, argon, and other elements. Okay? These elements were in the air at the same time the dinosaurs were. That means you, right now, wherever you're sitting, the air you're breathing could have been breathed by dinosaurs. And that, to me, is one of the coolest things ever. Thanks for watching.